Nurul Syahidatul Hanis binti Cendana alias Muhammad. Metric number 12DDT21F1032. Today our group will present problem-based task course DFN50133 Network Design. We from Department of Information and Communication Technology. Let me introduce my member group. Siti Sarah binti Ali Nodim, metric number 12DDT21F1018. The last is Nur Anis Hanani binti Suhaimi, metric number 12DDT21F1034. Number 1, introduction. In response to Masa Studios' business objective of establishing a dependable online sport news broadcasting platform, our network design around the creation of a secure and efficient infrastructure. The three-tier network model comprising the core layer, distribution layer, after to integrate essential functionalities that align with Masa Studios' specific requirement. At the core layer, dedicate core routers, facilitate high-speed routing and core service. The distribution layer consisting switch, manage data aggregation and distribution, while the access layer ensure end user connectivity and access control through access switch. To meet the need for secure data management, we introduce a dedicated server farm isolated within a private network, limiting external access. Two fundamental security measures are implemented in this context. Access control list (SCL) regulate traffic flow and prevent unauthorized access, while virtual local area network (VLAN) provide segmentation for internal network efficiency and security. Our network design also incorporates essential service to optimize functionality. Routing information protocol (RIP) ensures dynamic routing for efficient data transfers. Hot standby router protocol (HSRP) ensures high availability by designating a standby router, and spanning tree protocol (STP) eliminate network loops, contributing to overall network stability. Number 2 is network information. Logical topology. A logical topology is a concept in networking that defines the architecture of the communication mechanism for all nodes in a network. Using network equipment such as routers and switch, the logical topology of a network can be dynamically maintained and reconfigured. Logical topology contrasts with physical topology, which refer to the physical interconnection of all devices in the network. Physical topology refers to the interconnected structure of a local area network line, the method employed to connect the physical device on the network with the cables and type of cabling used or constitute the physical topology. This contrasts with logical topology, which describes a network's media signal performance and how it exchanges device data. Number 3, timeline and network resources. 3.1, this is our planning schedule to complete our PBT. We have task, duration and length of member group. 3.2, listing the device used in the design. Router PT. A router is a networking device that forwards data packet between computer networks. It operates at the network layer of the OSI model and routing tables to make decisions about where to send packets. It allows users to create, configure and simulate network topologies in a virtual environment. Switch 2960. The Cisco Catalyst 2960 is a series of switch commonly used in network environment. Its main function include providing Ethernet connectivity, supporting VLANs for network segmentation, managing quality of service setting, and enhancing network security through features like access control list. Servability. Servers are entirely different rate when compared to other end device. They have various functionality and also have space for two network interface. The module available for servers are the same as PC module, except that the server do not have the PC host and M1AM module link SYSWRT300N. The router allows you to share your internet connection between several computers that can connect via the draft 802.11n wireless protocol or via any 4-wire RJ45 Ethernet port. The router is also fully backward compatible with legacy 802.11b or G device. PCPT. PC can run application and service, allowing users to simulate different network scenarios. For example, we can use a PC to test web browsing, file sharing, or email application. PC also can communicate with other devices in the network, such as routers, switch, and servers. They can send and receive data using various networking protocols. Laptop PT. Laptop refers to a simulate and device that represents a portable computer within a network topology. This virtual laptop allows users to simulate the behavior of an user device in a network environment. Similar to virtual PC, a virtual laptop in packet tracer can be used for various purposes, including communication, configuration, application simulation, troubleshooting, and learning and training in networking concept.
My name is Siti Sarah binti Ali Nordin. My metric number is 12DDT21F108. I will continue the presentation about the installation and configuration. Step 1. We visit the official website of netcat.com using any web browser. Then we click the login button and select login option. Next, screen will appear. Click on the sign up option. Next, screen will appear and will ask for email and password and other simple details, and then fill them and click on register. Now the login screen will appear, and the next screen, enter the password and press the login button. Step 7. Dashboard will initialize. Now click on the results and choose download packet tracer option. Next, on the next web page, choose the operating system to download the packet tracer. Downloading will start automatically. Step 9. Screen is of license agreement, so click on I accept the license and click next. Now the packet tracer is ready to install, so click the install button. Then the installation process will start. Next is click on the finish button to complete the installation. An icon is created on the desktop, so run it. Then the interface is initialized and the software is ready to use. Next is device configuration. This is the address table for our PPT that is list the device that we use. First of all, we need to do the basic configuration for each router, and this is the configuration for ISP, main, backup, RA, RP, and RC. Next is IP address configuration at each of serial or port at the router. This is the configuration that we do at the ISP, main, backup, RA, RP, and RC. And next is configure wireless router at WR1, and this is for WR2. Next is we do the RIP configuration for our routing service. This is the configuration we do at the ISP router, and this is for RA router, this is for RP router, this is for IRC router, this is for main, and this is for backup. We do the RIP configuration because we want each of the end user from different network can connect to each other. After we do the RIP configuration, then we verify the connection between the end user, and this is the result from our PPT. Next is HSRP configuration. At core layer, we prepare two router for the service, which is backup and main. This is the configuration we do at the main router. After that, we test the service. For example, we use laptop 1. We at the command prompt, we translate to the RP loopback, and the path it use the normal path. After we shut down the serial 30 at main, then the path will laptop 1 use will be different from the before the shutdown. Next, this is the configuration we do at the backup. And after that, we test. For example, PCA go to translate to IP loopback, and this is the path that we use before the shutdown. And after we shut down the serial 20 at backup, then the path we use will be different. This means that our HSRP service is work because if one of the router is shut down, then it will use a different path to go to the destination. Next is spanning tree service configuration. Our road bridge is at switch MSA. Spanning tree is for when there is port that need to be shut down or having a problem, then the other path will be used. Next is SAL configuration. This is the configuration that we do at RA router, RP router, and RC router. We do the SAL configuration to block the ICMP from outside network to server farm, from private network to server farm, and also from outside to private network. We want to block the ICMP, and also we want to permit the access from outside to server farm, and from private or internet network to server farm using web browser only. After we do the configuration, then we test the service. First, PCB ping outside using web browser, and this is the result. Then outside ping database, and then laptop 2 ping database using web browser, and PC2 ping outside using web browser. User 1 ping outside using web browser. User B ping database using web browser. User A ping outside using web browser. And PC1 ping outside using web browser. This is the result that we get. Next is VLAN configuration. We do the VLAN configuration at switch MSA, which is VLAN 10 for staff and VLAN 20 for admin. After we do the configuration, we test the connectivity between the user in the same VLAN, and that connectivity must be successful. Next, I will pass the presentation to Nur Anis Hanan.
5. Maintenance and downtimes. 5.1 Hardware and software maintenance schedule. Masa Studios maintenance plan ensure the smooth operation of both hardware and software. Every month, we inspect physical components like servers and connection on the first Monday and update software, including patches and antivirus definition on the second Tuesday. Biannually, in January and July, we clean hardware for optimal performance and conduct software audits to ensure licensing compliance. Quarterly, we check backups and perform security audits to safeguard data. Annually, in December, we conduct a comprehensive hardware audit, and in June, we review the entire system for potential upgrades. These routines, complemented by agile emergency response, aims to uphold the reliability and security of Masa Studio IT infrastructure. 5.2 Disaster recovery should implement in the design. Disaster recovery is vital in safeguarding Masa Studio's network design against unforeseen events. Considering the services in use, RIP, HSRP, STP, SEL, and VLAN, the disaster recovery plan should align with these elements to ensure a comprehensive approach. First, data replication and backup. Implement regular data replication for critical servers in the server farm. Backup essential data to a secure off-site location. The aids in recovering data swiftly in case of data corruption or loss during a disaster. Second, redundancy for HSRP and VLANs. Ensure redundancy in high availability HSRP configuration and VLANs. This includes having backup routers and switches configured with HSRP and VLAN information, allowing for a seamless transition in case of a primary device failure. Third, STP optimization for rapid network recovery. Optimize spanning tree protocol STP settings for quick network recovery. That involves adjusting STP parameters to minimize downtime and ensure a faster response to changes in the network topology. And fourth, SEL backup and versioning. Regularly backup access control lists, SELs, and maintain version control. This ensures that if there's need to roll back change or restore a previous state, the necessary SEL configurations can be quickly implemented. 6. This is a prepared bill of materials BOM. 7. Summary. In conclusion, the proposed problem-based task (PBT) network design presents a comprehensive and tailored solution to address Masa Studio specific requirements for broadcasting online sports news. By strategically implementing a 3-tier network architecture with core, distribution, and access layers, we have established a secure, efficient infrastructure. The incorporation of a dedicated server farm within a private network and fortified with security measures such as access control lists (SCLs) and virtual local area network (VLANs) ensures a trusted environment. The inclusion of key network services including RIP, HSRP, STP, SEL, and VLANs provides Masa Studio with a versatile and reliable network foundation. Furthermore, the disaster recovery plan aligns with these services fortifies the network against unforeseen events, emphasizing the importance of continually in online broadcasting operations. The benefits derived from this proposal are multifold. Masa Studio can expect heightened security through restricted external access and enhanced internal communication capabilities. The three-tier architecture supports scalability, ensuring the network's adaptability to future growth and technological advancements. The disaster recovery plan, integrated with network services, mitigates potential risks and underscores our commitment to ensuring uninterrupted service. In essence, the proposed network design not only meets Masa Studio's immediate needs but also position the company for sustained success in the dynamic landscape of online sports news broadcasting, providing a secure, efficient and future-ready network infrastructure. 8. Reference. This is an example of our reference. That's all from my group. Thank you.